simplest approach to resolve collisions. In this technique, the value is already stored in a location. We are going to solve them using the hash function, which is h of k comma I equal to h dash of k plus I, where we can find the h dash of k in the preceding models, that is h dash of k equal to k into mod of m, where m is the size of the hash table, and here the I is the probe number that varies from 0 to m minus 1. If the hash table size, let us consider an example for solving the linear probing. Consider the hash table of size 10 and the list of elements, 8 elements. If there is no collision occurred in the problem, then use the formula h dash of k equal to k modulus of m. If any collision is occurred, then use the formula h dash of k plus I into mod m. Initially, the hash table is represented as empty, and we are assigning -1 to the every box. Here we are considering the table as empty. First, the key to be inserted is 72. As before, first the key is modulus with the hash table size. Here the hash table size is 10. 72 modulus of 10 is answer 2. So in index 2 we have to place 72. And the next element to be inserted is 27. 27 modulus of 10 is 7. In the place of 7th index we need to put 27, insert 27. Next element is 36. We get the answer as 6. So in the 6th position, here the next element to be inserted is 24. 24 modulus of 10 is 4. In the 4th index we need to insert 24. The next element to be inserted is 63. 63 modulus of 10 is 3. And we need to insert 63 in 3rd index. And the next element to be inserted is 81. 81 modulus of 10 is 1. So in the place of, in the index 1 we need to place 81. And the next element to be inserted is 92. 92 modulus of 10 is 2. Here the element is stored, already an element is stored in the 2nd index. So to reduce the collisions, to solve the collision, we need a formula that is h of k comma I is equals to h dash of k plus I modulus of 10. Here the h dash of k is 2 and I varies from 0 to 9. Initially the I is equals to 1. 2 plus 0 modulus of 10 is 2. Again we obtain the collision. Increment I equal to 1. 2 plus 1 modulus 10, and we get 3. In 3 we have already an element 63. Up to repeat the number of steps until the no collision cases occurred. Here 5, we got 5. In 5 we need to place 92. Next element to be inserted is 101. 101 modulus of 10 is 1. In the place of 1 we already have 81. So collision occurred. To resolve collision we are using this formula. Next, the same process that you have done in the before steps, perform the same procedure, where I equal to 0, h dash of k is 1, 1 plus 0 modulus of 10 is 1, again collision is occurred. Increment I equal to 1, 1 plus 1 modulus of 10 is equal to 2, again collision occurred. Increment I until the no collision cases occurred. Here in the case I equal to 7, 1 plus 7 modulus of 10, which is 8. In the 8th index we need to place the element 101. Here the hash table size is 10 and the number of elements to be inserted is 8. We have inserted all the elements, so the remaining places we need to put -1. By using this process we can reduce the number of collisions, but the drawback in this is the number of steps we take. It is very complex and the time complexity is order of n.